Hey guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a basic example of an electrophilic substitution aromatic reaction. And of course, we're going to look at different ways in which an electrophile is going to interact with the benzene or arene molecules in this kind of a discussion. So in that case, it's going to assist us on how to, of course, try to interpret the resulting or the products of an organic reaction that entails the electrophiles. Of course, which is going, of course, later to assist us also in discussing some of the concept that pertains to electrophilic substitution. So without further ado, thank you and welcome. So in this discussion, as I've said, we are going to look at basic steps that are involved in electrophilic substitution aromatic reactions. And of course, in these steps that I've talked about, there are going to be just 3 basic steps, which are going to represent the general electrophilic substitution aromatic reactions that we're going to discuss in our various topics. So in this case, the first step in this is a formation of a new sigma bond. So this is a formation of a new sigma bond. I'm going to use this symbol to represent the sigma bond. Now that we've discussed in one of our videos what the concept of a sigma bond is. And then this formation of a new sigma bond is from the carbon-carbon double bond of the arene molecule. Arene basically, as we said, it represents the benzene and its derivatives for the similar ring systems. Of course, the step number 2 is a removal of a proton from the removal of a proton from the carbon hydrogen. This is carbon hydrogen sigma bond. So when we're talking about a proton, that's a H positive or maybe a positive charge, which is basically from the arene molecule, that is hydrogen we're referring to. And then lastly, for this step or this reaction of a electrophilic substitution aromatic reaction, the last step that we're going to talk about is a reformation of the double bond. This formation of the carbon-carbon double bond and the restoration of aromaticity. So of course we're going to see that this concept of aromaticity and stability of these molecules that we are talking about, which are aromatic molecules, is going to be dictated, of course, by that concept of the stability is going to be dictated by that concept of restoring aromaticity that we have talked in our last step. So these are the major steps that we're going to look about, and we shall give a demonstration for this kind of a reaction that we are talking about. So for electrophilic substitution reactions, the concept of an electrophile that we have talked, of course, in one of our videos, we said that an electrophile is it's an electron poor species. It's an electron poor species, which means that it has a tendency to attract electrons. So in this case, we're going to just have a representation for the electrophile using this symbol. It's a positive charge, of course, from the law of attraction, something that likes electrons. Since they are negatively charged, then it will have to be positive charge. So in that case, we will have just a general demonstration of an electrophile that is interacting with an aromatic compound, which is benzene. And then we shall have a product, which is a substituted product that is going to look, general substituted product that is going to look like this. So as we can see, the the benzene molecule has interacted with this one to form that product, of course, which is a substituted benzene. And this is a general representation for that. So for the first case, that there is a formation of a new sigma bond from the carbon-carbon molecule of the arene nucleophile. So this one, as we have said, that it's known as an electrophile. This one is known as a nucleophile, and we're going to use that particular symbol to represent it. Now, of importance to us is that we are going to demonstrate using a mechanism of this electrophilic substitution aromatic reaction, so that we can be able to understand how the general substitution takes place. So we have an electrophile at that particular point that is interacting with an arene molecule, and we shall have those points. Now that we have talked about the concept of resonance, you can represent these bonds can be written here at this point, alternating different bonds, so long as they obey the octet rule for the stability of that molecule. So we are going to have what we call an intermediate molecule that we talked about in one of our videos, and said that the intermediate molecule is an entity that is arising within a sequence of stepwise, of course, or the steps of within a chemical reaction. So in this case, we're going to have an intermediate at this particular point that is going to have that one. So an electrophile at that particular point, and then we have hydrogen, and then lastly we shall have the product that we have written about. This is the product that is going to have an electrophile, and even at this point, so let's put it there, no problem. So in this case, we're going to look at the reaction mechanism for the formation of this electrophilic substituted product. So the first step that we mentioned about, step number 1, was the formation of a sigma bond from the carbon-carbon double bond in the arene nucleophile. So this one will come and pick this electrophile from this, and the formation of a new bond that we have mentioned that is going to appear in that intermediate species that we have written. So in this case, we're going to have a this one is wrong. I have to move this one here. So this is this can open. So we shall have this. It's an attack at that point. Then we shall have this one. This is E, H at that particular point, and there's going to be a positive charge at that point. So we talked about a nucleophile, which is a negative charge. So in this case, if there's going to be a removal of a proton by breakage of the carbon-hydrogen sigma bond that we are referring at this particular juncture, so we shall have a nucleophile. Let's refer that nucleophile to as P negative. So we shall have this nucleophile picking this proton at this point, and this bond will break, and then the result is that, so we move to this particular point to restore what we talked about aromaticity. So there will be a reformation of the carbon-carbon bond and a restoration of aromaticity, which of course has happened at this point due to the movement of this carbon there, that has resulted from the formation of the breakage of this sigma carbon-hydrogen bond at that point. So in actual sense, that is just a summary of the mechanism that takes place in electrophilic substitution aromatic reactions. So we're going to see how different electrophiles are able to dictate the nature or maybe a subsequent reaction for especially di or tri-substituted benzenes. So in that case, we shall stop there, and we shall be having complementary videos in order to supplement on what we have discussed in this kind of electrophilic substitution aromatic reactions and other similar reactions so of this nature. So in that case, that is it for today. Bye. God bless you.